Hello, welcome. And today we are going to figure out the problem factorial trailing zeros. So here is the problem. Um, so first we use the UMPI approach to understand the problem. So it's giving an integer n and return a number of trailing zeros in n factorial. So the input is an int and is 3 and its output is 0. So why? It's because the 3 factorial is 6, so there is no trailing zeros. But when n input is 5, so the output is 1 because when we use 5 factorial, it's 120. So there is 1 trailing zeros. So let's check. We want to find out how many zeros in the factorial, and how can we get the zero? We always use 2 multiple 5 to get the 0. So actually we want to find how many zeros. Actually we are find how many 2 multiple 5. So basically 5 is if a number that contains we use 2 and 5 to find out the number has how many 5 would enough if when one n is contains 5, it must be more than 2, so we get the 0. So actually we are find the how many to translate the question to how many 5, how many 25, and how many 125 in the input number of factorial. So here we step 1. We initialize. We need to initialize a counter to 0 to count how many 5 in the factorial. And step 2. We can use a for loop to check how many, because when I is 1, we always use I multiple 5. So when I is 1, it start with 1, and here is 1 5, and when I is 2, that means there is 25 is 2 5 in the factorial. So step 3. So every time we got in every iteration, an integer will division result of n by current multiple of 5 to the counter. So it's like n division to I. So we count how many times it should be, and we plus the count initial, we plus the counter. And finally, we just step 4, return the result. So here is so public. First, we want the output is int, and trail zero. And its input is also int. So we initialize the account to be 0, and we use for loop. So the int initialized will be 5. It's only 1, 5, and we keep use and division to I, so we can got. So if that is bigger than 1, we keep use I multiple 5. So when first is 5, so the next one is 25, and then the next one is 125. And we keep checking if that is division is bigger than 1, so we keep use the for loop. And after check, we always count all the division I. So after traversal, after the for loop, we will return the count. So that's what we want at finally. So let's check. So it's accept with 3 case, and we submit. So the time complexity will depend on because each iteration we use I is 5 is multiplied by 5. So we reducing the number of iteration needed to reach or exist n. So the time complexity will with big O and log 5. And the space would be because the space we don't use other data structures, so we use so the space is big O1. So here, so we can use the example to check the process again. So first input is 3. So initialize count is 0. So we can know that 3 cannot, when 3 division 5, it's 0. So it just won't go to the that loop. Then we just output 10. And the input if is 5. So we check here. 5 division 5 is 1, so we go to that the for loop, and 5 division 5 it will be the 1, and after that then we just got the what count plus 1, and we can figure out and the next for loop, I will be 25, and n cannot division to 25. It's just a 0, so it won't go to the for loop and finally return the count is 1. So this basically how I solve the problem. Thank you.